Good afternoon. In this video, I'm going to discuss steam distillation. Let me show you the PowerPoint. Okay. So in steam distillation, uh, the heat is supplied by steam. So this is special type of distillation is generally used for heat-sensitive products. So as you can see from this laboratory setup, uh, we're going to use two round bottom plus, and then on the first plus, this plus produces the steam. It's supposed to be wala tong Bunsen burner na to. So the first plus produces the steam, and then the steam is transferred to the round bottom plus, which contain the sample, and the volatile component of this sample will evaporate, and then this will be condensed out, and you will have the distillate product right here, and then what will remain on the container will be the bottom's product. So this is how steam distillation is done. I hope you still remember this from your organic chemistry laboratory. Okay, so regarding calculation, um, generally, when you use steam distillation, that the distillation temperature is lower. So why is that so? Usually, the system for steam distillation is made up of immiscible liquids. So, for example, oil and water, essential oil and water. So you have immiscible liquids. So when you have immiscible liquids, the total pressure prevailing on that system is PA star plus PB star. The sum of the uh, vapor pressures of the liquids. So, halimbawa, this is PH2O star, and this is the P essential oil star. So, relatively, the system has a high vapor pressure. So, since distillation operates during boiling, you will need a lower temperature since the vapor pressure is already high. You will need a relatively lower temperature to achieve boiling. So that's why the steam distillation operating temperature is relatively low. So aside from this equation, total pressure is equals to PA star plus PB star. I hope you still remember the difference of PA star and P sub A. This is the vapor pressure of pure component A, while PA is the partial pressure of A. So take note that in steam distillation, the total pressure is PA star plus PB star. And then the other equation is N sub A over N sub B is equals to PA star over PB star. So this is only true if you're going to assume that the system follows the ideal gas law, no? Um, since all the other variables in the ideal gas equation will cancel out, no? Because N sub A over N sub B, and then you have di ba PB is equals to nRT, no? PB is equals to nRT. Let me annotate this slide. So let me justify this equation. So as I previously said, this is only true if the system follows the ideal gas equation. So in ideal gas equation, it will be P B is equals to N R T. So for example, this is P sub A star, N sub A. So if you're going to isolate N sub A, you'll be on the other side of the equation, you will have, this is P sub A star. P sub A star times volume divided by R times T. So this will be true also for N sub B. So N sub B would be P B star B over R T. So when you substitute these two equations right here, substitute both of these equations right there. So you will have N sub A over N sub B is equals to P sub A star B over RT divided by P sub B star B over RT. Okay? So, itong dalawang equation lang ito yung gagamitin natin. This is the first equation and then this is the second equation in solving steam distillation problem. Okay, let's try this sample problem number 1. If naphthalene were to be steam distilled at 200 degrees Celsius and watt atmosphere, how many moles of steam would be needed per mole of naphthalene? Assume that the vapor pressure of naphthalene at 200 degrees Celsius to be equal to 475 millimeter mercury. So let's just recall our primary equation, no? Okay. So it would be, we're trying to look for, sorry, forward. Okay. So if naphthalene were to be steam distilled at 200 degrees Celsius and watt atmosphere, how many moles of steam would be needed per mole of naphthalene? Assume the vapor pressure of naphthalene at 200 degrees Celsius to be equal to 475 millimeter mercury. So just try to recall the basic equation of steam distillation. Number of moles of water divided by number of moles of naphthalene is equals to vapor pressure of water or steam divided by the vapor pressure of naphthalene. So in the problem, you have the vapor pressure of naphthalene that would be 475 millimeter mercury. Tapos per mole of naphthalene, so number of moles of naphthalene is 1. So ang tinatanong is how many moles of steam? So number of moles of steam is unknown. Tapos the pressure of water is simply 1 atmosphere minus 475 millimeter mercury or 760 minus 475 millimeter mercury. So It's that simple. I know we're just going to use the two equation that I already introduced earlier. No, let's try to write that. Number of moles of steam divided by number of moles of naphthalene is equals to partial vapor pressure of steam divided by vapor pressure of naphthalene. The number of moles of steam is this unknown. The number of moles of naphthalene is 1. Pressure of steam is, that would be 760 minus 475. Okay, these are in millimeter mercury, all over 475. These are all in millimeter mercury. So just use your calculator to find the answer. That would be 760 minus 475 divided by 475. That would be 3 pips or 0.6. Ano? So number of moles of steam is 0.6. So that would be letter B. Let's try another one. Glycerin is steam distilled at 190 degrees Celsius under 26-inch vacuum. A test shows a steam consumption of 1 pound per pound of glycerin distilled. What percent excess steam referred to the theoretically needed is actually used? So vapor pressure of glycerin at 190 degrees Celsius is 29 millimeter mercury. So if we're going to use the standard equation, number of moles of steam divided by number of moles of glycerin is equals to vapor pressure of steam divided by vapor pressure of glycerin. We know the vapor pressure of glycerin is given 29 millimeter mercury. Tapos the total pressure is 26-inch vacuum. So we need to calculate the total pressure and then convert that to millimeter mercury. By the way, when you say 26-inch vacuum, what you're going to do is you're going to subtract this to 1 atmosphere. So what in terms of inches, that would be 29.92 inch of mercury. So that would be 3.92 inch of mercury. That's the total pressure. So from that, you can calculate the pressure of steam. So 3.92 inch of mercury minus 29 millimeter mercury would give you the pressure of water, of steam. And then number of moles of glycerin is 1 pound all over the molar mass of glycerin. So glycerin contains 3-hydroxy. Um, so that would be glycerin. Glycerin is, let me annotate this. So glycerin is contains 3-hydroxy compounds, and then Fill this up with hydrogen. So you have C3. That would be 3 times 12 plus 3 times 16 plus 8. So the molar mass of glycerin is 92. Okay. And then the total pressure is P is equals to 29.92 inch. This is 1 atmosphere, no? Minus 26 inch. So total pressure is 3.92 inch. So if you want to convert this in millimeter, first let's convert this to centimeter. So times 2.54. Tapos convert this to millimeter. There are 10 millimeters per centimeter. So the total pressure is 99.57 millimeter mercury. Okay, so with these numbers, let's use the basic equation of ano, no? Of steam distillation. Number of moles of water or steam, number of moles of glycerin is equals to P star steam or water divided by P star glycerin. Okay, so this would be x divided by 18. We need to find the number of pounds of water. And then 1 divided by 92. And then P star water, that would be 99.57 or 568 minus sorry, lumipat yung problem. Lumipat yung. Okay. $99.57, that's the total pressure minus the vapor pressure of glycerin is 29 millimeter mercury divided by the vapor pressure of glycerin 29 millimeter mercury. Let's try to calculate this. So I'm getting something like 0.476. X is equals to 0.476. So this is the theoretical, ano? The theoretical pound of steam. per pound of glycerin. This is the Charepy type. So if we're looking we're looking for the percent excess steam. So percent excess steam, that would be actual minus theoretical divided by theoretical times 100%. So that would be 1 minus 0.476 divided by 1, okay, so times 100%. Sorry, divided by 0.476 times 100%. So that would be well, 110%. Ano? You're supposed to get 110%. And that would be letter A. I hope you can solve this on your own. Ano? I hope that you're able to follow my solution. Okay? So let's go to the last problem for steam distillation. Sample problem number 3. A totally immiscible liquid system composed of water and an organic liquid boils at 90 degrees Celsius when the barometer reads 734 millimeter mercury. The distillate contains 73% by weight organic liquid. The question is, what is the molecular weight of the organic liquid? So for this particular problem, you need to find the vapor pressure of water at 90 degrees Celsius using a steam table. Okay. So basically, you're just going to use the same equation. Ano? Number of moles of water divided by number of moles of organic liquid is equals to vapor pressure of water divided by vapor pressure of organic liquid. So basically in this problem, in order to find the vapor pressure of organic liquid, after finding the vapor pressure of water from the steam table, you just subtract that to 734 and then you'll be able to find the vapor pressure of organic. So the distillate contains 73% by weight. So if our basis is we're going to use 100 grams, now if we have 100 grams of distillate, so therefore we will have 27 grams of water. So 27 grams of water divided by 18, and then we have 73 grams of organic liquid, and divided by the molar mass of organic liquid, and then this would be equal to P star H2O at 90 degrees Celsius. Okay, P star H2O from steam table is 70.11 kPa. Ano? So you need to convert this to ano, no, to millimeter mercury. So just multiply this by 760 and then 101.3. So P star H2O is 526, 526 millimeter mercury. So P star H2O is 526 millimeter mercury. And then P organic is 734 minus 526 millimeter mercury. So the molar mass of organic is, let's try to solve this in your calculator. So 1, 2, 3. No, the molar mass of the organic is 120. So that would be letter D. Okay, so I will try to upload 2 more videos and then um, we'll have our midterm on. Okay, we can have our midterm on Friday, 4 p.m. We'll have our midterm on Friday, 4 p.m. So see you on the next video.